There we go. Guys, if we move, hey, Logan, we're doing this. If you move things in space like we did yesterday, you'll create heat. Draw a picture. You have a lead shot, okay? Just a lead ball right here, and you're going to drop it a height of 1.5 meters, and it has a mass of 0.50 kilograms. And how many times would you have to move that in order to raise the temperature of it by 10 degrees Celsius? I'm sorry, 1 degree Celsius. So what this means is work is measured in joules, and that is equal to Q. All right, it's equal to Q. Really, I think it's well, no, this will work out. Okay, how much potential energy does that have, Ariana? How much potential energy does that have? How do I get potential energy? Because potential energy is equal to work is equal to Q, because now we have a frictionless environment. You see that, Chris Parham? No friction. So this is no friction. So in this situation, work is totally equal to Q. Does that make sense, James? No energy loss. Just move to one another form. Yes? So calculate the potential energy. What's the potential energy of that ball? 7.35 joules. Okay. 7.35 joules is the kinetic energy. Well, what would be the Q of that same lead ball if you raised it by 1 degree Celsius? So now what you need to do is tell me the heat capacity for lead out of that chart. So go look at the chart way back, flip back, and look up the heat capacity for lead, please. 130. Okay, so I have a 0.50 kilogram, and I have a heat capacity of 130 joule per kilogram Kelvin, and the 1 degree Celsius change is the same as 1 Kelvin change. It's just a temperature difference. 130 times 0.5, what's that? 70, 65, 65 joules. Okay, 65 joules. So how many times would you need to drop the thing to get 65 joules of energy? If your potential energy is 7.35 from that height, it's very simple. 7.35 joules times X equals 65 joules. 9 times. 8.84. 8.84 times. Now, I'm guessing that it strikes the floor, the heat loss, no friction with the air, and when it impacts the ground, there's the heat, right? So it's you're translating it to heat by impacting the ground. And if you drop it 9 times, it will heat up by 1 degree. Let me ask you this. If you took your hands and put them apart 1.5 meters, right? And then clapped them together 9 times, would you heat up your hands? Try it. Yes, you would. Okay? No waiting between, just as fast as you could. Would you heat up your hands? Yeah. There you go. Your hands get hot, don't they? Because of the impact. Okay? The work you put into dropping the ball, is equal to the thermal energy that is outputting. Okay? So I want you to do the next one. If I get 20 likes on this one, I will show you the answer for the next one. Fourth period dude physics DHS. Like, comment, subscribe, smash the bell.